All right, well, hello physics students and welcome to this video lecture that's going to be first reviewing momentum concepts and then talking about the conservation of momentum. Okay, so previously in class we said that momentum is mass in motion. So if an object is moving, it has some amount of momentum. And our mathematical definition for momentum, we said that momentum is equal to mass times velocity. Now our units for momentum, we're multiplying mass times velocity. So we just have to look at what our units are for those two quantities. So our units for mass are kilograms, and our units for velocity are meters per second. Okay, so those are our basic units for momentum. Now, you might also see the units written as newtons, Newton times a second. Okay, that is the same thing as a kilogram times a meter per second. Okay, I can go into the derivation right now, but that just takes a little too much time, and I don't want this video lecture to inhibit your weekend in any way. So there's our mathematical definition for momentum. Now, we can have changes in momentum, okay? And changes in momentum are caused by forces being applied to a particular object in a certain amount of time, okay? So we say that change in momentum is equal to force times time. Now, because of that force being applied in a certain amount of time, we're going to have a change in the motion of that object. So this is also going to be equal to, or a change in momentum is also equal to mass times a change in velocity. Now remember that whenever we say a change in velocity is always V final minus V initial, okay? Now this change in momentum, we have a specific term for that, and it's called impulse. Okay, so change in momentum is called impulse. Now, it's also important to know that impulse is a change in momentum, so our units for change in momentum are simply the units for momentum, kilograms times meter per second, okay? So the concept of momentum, just to recap, is pretty basic, okay? If an object's moving, it has momentum, and changes in momentum, impulses, are caused by forces applied in a certain duration of time. And the reason that the momentum changes is because you're going to have a change in your motion. You're going to have a change in velocity. Okay, so the next slide, we're going to be going through conservation of momentum, which some of you were introduced to today with the POGL that was done in class. All right, so conservation of momentum is a pretty basic idea, and we can kind of relate back to our idea of conservation of energy, where we said that however much energy we had in a system initially, we had to have that same amount finally. Well, the same thing holds true with conservation of momentum, okay? So if we have some initial amount of momentum in a system, we have to have that same amount finally in that system, okay? So I think the best way to show you conservation of momentum is just by going through a problem here. So let's say that I have two railroad cars, okay? Two railroad cars here. So I have car 1 and car 2. Now car 1 has a mass of 100 kilograms, and car 2 has a mass of 150 kilograms. Cart 1 has an initial velocity of 1.5 meters per second, and cart 2 is at rest. Okay, so we have to look at both objects when we're utilizing conservation of momentum. Knowing that car 2 is at rest, the only object in this system, okay, this is our system, our two-car system here. The only object that has momentum initially is car 1. So our momentum initial then is just going to be equal to M1 times V1. And if we do that basic math there, we're just going to get 150 kilograms times meters per second, okay? But now let's say that these two cars, after the collision, okay, after the collision, let's say that car 1 and car 2 actually join up, okay, they stick together, and they start moving and they're going to start moving at some velocity, okay? We don't know what that is. We can figure it out. But we know that that final amount of momentum that car 1 and 2 have together has to equal that initial amount of momentum, okay? So we know that, let me see if I can make this smaller here and scoot it up. I'm struggling with the technology right now. Okay, here we go. So we knew that initially in this system, we had a momentum initial that was 150 kilograms times meter per second, okay? We know that that has to also equal our momentum final. So we can then figure out what this final velocity is of those two carts together, okay? Understand that if these two carts stick together, we can consider that to be just one object. So momentum final is going to equal mass of 1 plus 2 times that velocity final, okay? Times that velocity final. So we know this. We know this. We can easily find this by just adding the mass of those two carts together, and then we can find velocity final, okay? So if we just do this algebraically real quick, V final is going to equal momentum final divided by M1 plus M2, okay? So then we're going to have 150 kilograms times meter per second divided by, let's see, it's going to be 250 kilograms. That's the mass of those two carts together. Okay, and if we do that math here, I didn't calculate this out, 150 divided by 250, we're going to get a final velocity, ooh, I don't know what happened there, final velocity of 0.6 meters per second. Okay, so big idea with conservation of momentum. We're going to be going through some more problems like this in the coming days to get really comfortable with this idea. But conservation of momentum, whatever amount of momentum we have initially, we have to have finally, okay? And you could see that in this sample problem, okay? The only thing that had momentum initially in this system was cart 1. So as soon as we calculated the momentum for cart 1, that was our initial amount of momentum, okay? Now, after that collision, those cars stuck together. So those two cars now together had to have the same amount of momentum finally, or after that collision, as they did initially, okay? And then with that, we were able to find what that final velocity of those two carts were. So there's your introduction to conservation momentum. There's your review or your recap of momentum in general. And in the coming days, we're going to be applying this through the lab and through problem solving. So have a good weekend, physics students. Take care.